Hello and welcome. The first case in job sequencing, Johnson's algorithm, and the case of processing n jobs on two machines. In this case we have two machines, machine M1 and M2, and we have 7 jobs against us. And the time for each job on each machine has been given in terms of number of hours. Job 1 requires 20 hours on machine 1 and 25 hours on machine 2. Similarly, job 2 requires 90 hours on machine 1 and 60 hours on machine 2, and so on. And it is to be understood that the logical sequence of processing is first the job is to be completed on machine 1 and then only it can be done on machine 2, and ultimately the job is completed. Now our aim is to complete all n, or in this case 7 jobs with minimum time elapsed. For that purpose, what should be the sequence of the jobs? Which job should be done first, which second, which at last? And for this purpose we are going to use Johnson's algorithm. The simple pattern or steps to be followed: first of all, we have to find out the job with the minimum time required. The job with the minimum time required. Which one is the job with minimum time required? Out of all 7 into 2, 14 different time slots have been given. This 15 is the lowest. Now check the least time in the outstanding jobs, all outstanding jobs, is on which machine. If it is on machine 1, then it should be placed on the left hand side or on the earlier order in the job sequencing chart. If the least time is on machine 2, then that job will be placed on the right hand side in the job sequencing chart. That means the later preference order. So in the 6th job, minimum time of all is on machine 1. So we should give first preference to job 6. So out of these 7, first we shall perform job 6. Now 6 will be on first. What about remaining 6? 1, 2, 3, 4, 5 and 7 job number. Again the minimum is 20 and that is on 2. On machine 1, both are on machine 1, but for job 1 as well as job 4. This is the situation of tie. Now the tie is on machine 1. If the tie is on machine 1, first let us get the total time required to complete the job on both the machines. In case of job 1 it is 20 plus 25, 45, and on job 4 it is 20 plus 30, 50. If the tie is on machine 1, tie in the least time for 2 or more jobs is on machine 1, the job with the lowest total time will be placed on left hand side. So job number 1 on left hand side and job number 4 on right hand side to that. So job 4. Now what? Again same process for the remaining 4. Yes. Now remaining 4, job number 2, 3, 5 and 7. Which one has the minimum time? C. 60 and 50. So 50 is the lowest. Job number 7, machine 2. Since the lowest time is on machine 2, we have to place that job on the right hand side. Or we prefer to perform this job at later stage. Now for remaining 3, the lowest time is 60 in job 2, which is on machine 2 again. So we are going to place it on left hand side, machine job number 2 on 6th order. Now remaining 2, the lowest time is 75. Again it is on machine 2, so we have to place it on right hand side. Job number 3. Yes, okay. And the last is job number 5, only one place, 4th. So in this way, following Johnson's algorithm, the job sequencing chart shows that first we would complete job 6, then job 1st, then 4th, then 5th, then 3rd, then 2nd, and the last will be the 7th. Now the next step is to prepare the statement showing minimum total time elapsed. If we follow this sequence, what would be the total time to complete all the 7 jobs? Okay, first our choice is 6. The time required on 6th job on machine 1 is 15, but its time in will be 0. That means we switch on the machine and put the job on machine 1. That is starting point, and it is always taken as 0. It requires 15 hours. So 0 plus 15. Timeout will be 15. And after 15 hours of starting the work, the job number 6 will be placed on machine number 2. Till this point of time, machine 2 will be waiting. And if the machine is waiting for a specific duration, that duration is called idle time. Because since the job number 6 is completed on machine 1, machine 2 will be idle. Only after completing the job on machine 1, we can put it on machine 2. Now at the end of 15 hours, it will be on machine 2, and on machine 2 it requires 35 hours. So 15 plus 35 will be the time out on machine 2. Now second choice is job number 1. Job number 1. On machine 1, the starting time of job number 1 will be 15th, end of 15 hours. So its time in is 15, because only after completing 6th job on machine 1, we can start job 1 on machine 1. So 15 will be its time in, and 15 plus 20, the time required to complete job 1 on machine 1. 15 plus 20 will be time out, that is 35. That means at the end of 35th hour, job 1 was completed on machine 1, but at that time machine 2 is not free. It is since busy on doing job number 6. So 35 or 50, whichever is higher will be the time in. 35 or 50. Time out on previous machine and time out of previous job on current machine, whichever is higher. 35 or 50, whichever is higher will be the time in for job number 1 on machine 2. This is very important point. Please try to understand 35 or 50, whichever is higher. Because at the end of 35 hours, machine 2 is still busy on job number 6. So we cannot put job number 1 on machine 2. Job has to wait. This is the thing. Job has to wait. And when job is waiting, there is no idle time. Idle time is called when machine is waiting. Now 50 plus job number 1 requires 25 hours on machine 2. So 50 plus 25, 75 will be time out. 75 will be time out. Third choice is job number 4. It is turn of job number 4. First on machine 1. Now machine 1 is free at the end of 35 hours. So 35 will be the time in for job number 4 on machine 1. And machine job number 4 requires 20 hours on machine 1. So 35 plus 20 hours, that will be 55. At the end of the 55th hour, job 4 will be completed on machine 1. But at that time, machine 2 is busy on job number 1. So job has to wait 55 or 75, whichever is higher, will be time in for job number 4 on machine 1. Because only at the end of 75th hour, machine 2 can take the job number 4. Again, this is the case that job was waiting. When job is waiting, there is no idle time. Idle time is always only when machine has to wait for the job. Machine is empty. Yes, 75. Now job number 4 requires 30 hours on machine 2. So 75 plus 30, 105. That will be time out for job number 4 on machine 2. No idle time because machine was not waiting. Now our next choice is job number 5. Job number 5, its time in on machine 1 will be 55. Because at the end of 55th hour, machine 1 has completed job number 4. So machine 1 now can take job number 5 at the end of 55th hour. 55 plus job number 5 requires 90 hours on machine 1. 90 hours. 55 plus 90. So it will be 140. Yes, 145. Is it? I'm very sorry, it is not 90, it is 120. It is 120. So 175. At the end of 175th hour, job number 5 will be completed on machine 1. Now on machine 2, the scenario is at the end of 105th hour, machine 2 has become free from job number 4. So from the end of 155th hour to the end of 175th hour, machine 2 was waiting for job. It was empty. So this is the case of idle time. 175 minus 105. So idle time comes to 70 on machine 2. Mind well, on machine 1, there can never be idle time in between the jobs. It continuously works. Only machine 2 and subsequent machines has to wait. When machine is waiting, there is idle time. Now again, time in on machine 2 will be 105 or 175, whichever is higher. 175. Try to understand the situation. At the end of 105th hour, job 4 was completed on machine 2. And for next 70 hours, the machine 2 is waiting for the job coming from machine 1. Okay? Now, job number 5 requires 90 hours on machine 2. By mistake, I had written 90 at on machine 1, but later on I rectified the error. 90. 175 plus 90. 265. Okay, now next choice on machine 1 is 3, job number 3 rather. Job number 3 requires 80 hours, but the starting point will be 175. After job number 5, machine 1 takes job number 3. Okay, 175 is the timing for job 3 on machine 1. Job 3 requires 80 hours on machine 1. 175 plus 80. 255. At the end of 255th hour, job number 3 will be completed on machine 1. But at that time, machine 2 is still busy in completing previous job number 5. So, machine is not waiting, job is waiting, so there is no question of idle time. Time in for job number 3 on machine 2 will be 265 or 255, whichever is higher. 265. Because still machine 2 is busy on job 5. Only after completing job 5, machine 2 can take job number 3. So job has to wait for 10 hours. That is the explanation of the situation in very simple words. 265. Job number 3 requires 75 hours on machine 2. 265 plus 75. That will be 330. No, 340. Sorry. Okay, now next choice is job number 2. Job number 2, the timing will be 255 on machine 1. Job 2 requires 90 hours. 255 plus 90, 345. 345. See, timeout. And here timeout is 340. So for 5 hours machine 2 is empty. Machine 2 is waiting to get the job. So this is the case of idle time. Yes, machine has to wait for 5 hours. Now 345, 340 or 345, whichever is higher. 345 is timing for job 2 on machine 2. Job 2 requires 60 hours on machine 2. 345 plus 60, 405. Total time elapsed 405. Now the last 7th job. Time in of 7th job on machine 1 is 345. 7th job requires 65 hours. 410. 410 or 405, whichever is higher. 410. Again, at the end of 405th hour, machine 2 was free, but has to wait for 5 hours to get the job completed from machine 1. Again, this is the case of idle time. 5 hours idle time. 410 minus 405. Timing for job number 7 on machine 2 is 410 and it requires 50 hours. 410 plus 50, 460. So we can say that in total 460 hours we can complete all the 7 jobs on these 2 machines in order, machine 1 and machine 2. Now, so first of all, minimum total time elapsed equals to 460 hours. Idle time on machine 1, it will be summation of all these 85, 90, 95 hours. Idle time on machine M1 we are going to calculate, and on machine 2 we have already found through that column 95 hours. Now a very strange point, machine 1 remains empty for 50 hours after completing job number 7 till machine 2 completes job number 7. So in that case it is 50 hours, that is total time elapsed minus the time out of the last job on machine 1. So in this way we can prepare this very simple statement showing the minimum total time elapsed and idle time. And if there are more than 2 machines, machine 3, 4, 5 and so on, it is advisable to prepare such type of column of idle time for each machine, but I don't advise because it extends the size of the statement, and in your examination you have to prepare this kind of statement in any one side of your answer sheet or at the most covering all the 2 sides of answer sheet. So it is not feasible to prepare this kind of very big statement, very broad statement in your answer sheet when you are writing the answer sheet manually. So I suggest this method of finding the total idle time of any machine. Total time elapsed minus the last time out of the particular machine. That will give you the accurate idle time of that machine, total idle time of that particular machine. So we prepare this kind of column in case of 2 or 3 machines only, where there are many number of machines. We need not require to prepare this kind of column, separate column of idle time. That's it. Thank you very much.